let's look at some of the slightly counterintuitive. Let's say we have two boxes, one of which is 2 kilograms, one of which is 10 kilograms, and they're both dropped from the same height. If you ask someone which one do you think will hit the ground first, most people are going to say the 10 kilogram box. But in fact, both of those objects will fall at the same rate and will hit the ground at the same rate. That's because the 10 kilogram mass will have a bigger weight. There will be a bigger force in it pulling it downwards than the 2 kilogram mass. But the 10 kilogram mass, because it's heavier, that force won't have as big a much impact on it as it would if that same force was on the 2 kilogram mass. So even though the force is bigger, the acceleration of both these objects will be exactly the same. Now, on Earth, the acceleration of all objects is 10 meters per second squared in a downwards direction. So for instance, if I drop an object on Earth from rest, after 1 second it'll have a speed of 10 meters per second, after 2 seconds 20 meters per second, 3 seconds 30 meters per second, and that's all objects, from a box to a coin to anything that falls. Now, that's a simplified version of it, because if there's other forces such as air resistance or friction, that's going to affect the acceleration. So most of our questions, we're going to assume that's not true, that there isn't any friction or air resistance on the objects. This is one of the experiments they did on the Apollo missions, where an astronaut dropped a hammer and a feather, and both of them hit the ground at exactly the same time, because of course on the moon there isn't any air resistance because there's no air. Okay, so we can take the acceleration of any object on Earth to be 10 meters per second squared. You would be expected to know that, so the question may not state it is Earth, this is the acceleration. Any object that is dropped on Earth, we can take A to be 10 meters per second squared.